Hi everyone. This review is to talk about our last assignment, which was a mixed review covering lessons 7.1 through 7.3. It's on page 410, and you were asked to do number 6 through 20. This video is probably going to have to be done in at least two parts because I want to cover quite a few of the problems. So I'm going to be explaining every single problem that anyone missed. So there are quite a few, but I think it's really important for you to understand how to solve all of these so that you do well on the Chapter 7 test. So everyone got 6, 7, and 8 right. You should turn to page 410 and follow along. I should have said that. So everyone got 6, 7, and 8 right, so I'm going to start with number 9. So here's what you're given for number 9. It's a trapezoid. It's important to notice that it's not an isosceles trapezoid, but it is a trapezoid nonetheless. So the first thing that we have to figure out is the height so that we can figure out the area of this figure. So the height right here isn't given, but we know it's part of a triangle with which we can work. So we have a triangle here. It's 90 degrees. We know it's 60 degrees here, so we can assume that this top angle is 30 degrees. So that means it's a 30, 60, 90 degree triangle. So we need to use the formula we keep having to use to solve for this side here. So we know that the bottom is 6. We don't know the hypotenuse and we don't know the long leg. But we do know that the long leg equals the short leg times the square root of 3. Now that is just the formula that we are given for the 30, 60, 90 degree triangle theorem that we've used several times now. So the long leg here, we still don't know what that is. I'm going to put just double L to represent that. But we know that SL is 6 times the square root of 3. So that means that this length here is 6 times the square root of 3. So we have the height now. All right. So let's just break this figure up into 3 parts to figure out the area. Now the first thing we can do is figure out the area of this triangle that we were just working with. Now to do that, we have to use the triangle area formula, which is height times base divided by 2. Okay, so we will take 6 times the square root of 3 times 6, and then divide that by 2. Now you can do this however you would like. I'm going to make 6 times the square root of 3 times, I'm going to simplify these 2 to 3. So then I have 6 times 3 is 18 times the square root of 3. Okay, so 18 times the square root of 3 is the area of that triangle right there. I'm going to write that over here so I don't forget, because I'm going to have to add the other areas to figure out the full area of the figure. So I'm going to break this here, and I know that this length is 11 millimeters. So to figure out the area of a rectangle, you just take base times height. So the base is 11 millimeters, the height is 6 times the square root of 3. So 11 times 6 times the square root of 3 is going to be 66 times the square root of 3. So now I have the middle rectangle already done right here. I have this triangle over here already done. Now I need to do this last triangle over here. Some of you, I think, assumed that this triangle was the same as this one, but it's not. We can figure this length here, the 15 millimeters is talking about from here to here, okay? And we know 11 millimeters is from here to here. So from here to here is 15 minus 11, which is 4. So it's not the same. This one has a base of 6, this one has a base of 4. So to figure out this one, we need to take base times height, so 4 times 6 times the square root of 3 divided by 2. So I'm going to simplify this and say it's 2 times 6 times the square root of 3, which is 12 times the square root of 3. So I need to add that to this, plus 12 times the square root of 3. So this is going to give me my area. I have to add these 3 together. So let's see here, 66 plus 18 would be 84. 84 times the square root of 3 plus 12 times the square root of 3 is 96 times the square root of 3. And that is the answer, 96 times the square root of 3. So that was a long one, but each part individually isn't too bad, too hard. You just have to add it all together once you're done. Number 10, we have to find the area of a rhombus. We have the formula for that. There's a reminder of it on page 409, so you can flip back on the previous page. But the area of a rhombus is 1/2 times diameter 1 times diameter 2. So this is the diameter, this is the diameter. We have one of the diameters already, so we can write A equals 1/2 times, this diameter would be 8 plus 8, right? So 16. And then we need to find what is the second diameter. We need to know this length right here, the shorter one, okay? So in order to do that, we need to pull out a triangle. A lot of these are always having to do with triangles, so look for triangles that you can work with. Luckily, we have here, oh, we also know that this side is 10. Okay. We know that if this angle is a 90-degree angle, then the one below it also is. So we can pull out this triangle here. Oops. That's a good one to work with. You could have worked with any of them, but I'm going to pull out this one right there. I know that the bottom is 10, that's the hypotenuse. I know that this is 8. I don't know that this is a 30, 60, 90-degree triangle, but I do know it's a right triangle. So what I can do is use the Pythagorean theorem. So I can say the hypotenuse, or remember, a squared plus b squared equals c squared. C squared is the hypotenuse. So I can say 8 squared plus b squared, we'll say this is b, equals 10 squared. Okay. 8 times 8, 64, plus b squared equals 10 times 10 is 100. All right, and now I need to take 100 minus 64, which is 36. Sorry. B squared equals 36. So that means that b equals the square root of 36, which is 6. 6 times 6 is 36. So b is, it already kind of looks like that. b is 6. So I can fill in 6, 6 for the shorter diameter. 6 plus 6 is 12. So the second diameter is 12. So from here, I'm going to take 16 times 12 divided by 2. I'm going to do that in my calculator right now because I don't have that offhand. 16 times 12 is 192, divided by 2 is 96. So the area of this is 96, this happens to be in feet, I didn't write that in, but 96 feet squared. And that's the answer, 96 feet squared for number 10. Number 11 at first glance might look like a rhombus, but it looks like it's actually a kite. It doesn't really matter though because the formula for solving the area is the same for those two figures. So what we need to do is take 1/2 times the first diameter times the second diameter. So let's say that this short one is diameter number 1. We are given this length, which is 6.5, and this length, which is also 6.5. So we add those together to get the full length of the diameter, which would be 13. So we can say A equals 1/2 times 13. Now we need to get the length of this one. They give us all the information for this problem, so it's a little easier than the other two. They told us that this is 10 and that this is 8, so 18 is going to be the second one. So let's take 13 times 18 is 234. And we'll take that times 1/2 or divided by 2, however you want to look at it. The area is 117, and these are centimeters, so centimeters squared. And there's the answer. That one was a lot easier. For number 12 through 14, we're going to need to use this idea. To figure out the area of any polygon, you can take 1/2 times the apothem times the perimeter. Now, it says that we need to draw a figure, a triangle with a radius of 4 inches for number 12. So I have the figure drawn right here. This is a triangle. The radius is 4 inches. So in order to figure out the area, we need to figure out several things. The first thing we need to do is figure out some angles in here so we can see which formula is going to help us figure out the perimeter and the apothem. So if we draw all of the radii in this figure, we can separate it into 3 sections. We know that all of these angles, these 3 angles added together, equal 360. So I'm going to divide 360 divided by 3, and I get 120. So each of these angles is 120 degrees. Now the only angle I really need is half of that to figure out the apothem. So if this angle was 120 degrees, then I know that this angle is 60. All right, once I know that that is 60, and I've drawn the apothem, which is always perpendicular, I know that's 90, then I know that this is 30. So I have a 30, 60, 90 degree triangle. So I can use our old formula that we've been using for the 30, 60, 90 triangle. All right. So I know that the hypotenuse is 2 times the short leg. So the short leg equals, the short leg times 2 equals the hypotenuse. Okay, that's how it is. I can substitute because I know the hypotenuse is 4. So I can take 4 divided by 2 to get the short leg by itself. Short leg equals 2. So I know that this apothem is 2. All right. Now once I know that, I can figure that the long leg, the long leg is, long leg equals short leg times the square root of 3. So long leg is 2 times the square root of 3. So I'm going to fill that in. 2 times the square root of 3 is from here to here. All right. So I figured out the apothem is 2, so I can put A equals 1/2 times 2p, but I still need to figure out the perimeter. Sorry, I'm on a bounce ball. So 1/2 of this length is 2 times the square root of 3, so the full length is going to be 4 times the square root of 3. Now I need to assume that all of these sides are 4 times the square root of 3. So 4 times the square root of 3 plus 4 times the square root of 3 plus 4 times the square root of 3, would be 12 times the square root of 3. You just add 4 plus 4 plus 4 and then square root of 3. So 12 times the square root of 3 is the perimeter. So let's say A equals 1/2 times 2 times 12 times the square root of 3. All right. So once we have that, we can simplify this a little bit. 1/2 of 2 is 1, and 1 times, I can take 2 divided by 2, and that means it's 1 times 12 times the square root of 3. I'm sorry, I think I'm doing that wrong. I'm just going to do this on my calculator, actually. Let's figure out what 1/2 times 2 times 12 times the square root of 3 is. Oh, my computer. Okay, I'm going to pause it and do it on my computer. So yeah, it is what I was doing before, but I was kind of complicating it. If you take 1/2 times 2 times 12 times the square root of 3, you're going to get about 20.8 inches squared, which is the answer. So yeah, you could take 1/2 times 2, which is just 1 times 12 times the square root of 3. So as you were doing it, you might have noticed that the answer just is 12 times the square root of 3, which is about this. And in this problem, it asks for the answer to the nearest tenth. Okay, so this is part 1. I'm going to do 13, 14, 16, and 19 in the next video.